Hello and welcome back. It's Michael again, and we are continuing now with our contagion series. In the last episode, I mentioned that one of the next things we want to do is looking at painting a graph. However, there's one other thing I want to talk about before, because I promised at the beginning of this series that we would talk about code quality as well. So I will spend one episode with discussing alternative implementations and code quality, and then we will add more functionality. But first we will improve or think about improving the implementation of our program so far. Just to recap where we were when we run our simulation now in Greenfoot here. We have the people running around, we can see the epidemic spreading, and we also have here at the top the number of infected people and the maximum. If we look at our code again for how we have done this, that was done in the world class, the counting and display of the people. So we have here our display info method, and in this method at every act step we go through, we create a new list, we get the list of all the people in the world, and then we go through the list and count how many are infected. Now there is one alternative way how we could do this. Instead of counting the people every time from scratch at every act step, so at every act step essentially we forget how many we had infected previously, and we just look at every person again and count from scratch again how many are infected. That is one way to do it. There's an alternative that I want to briefly discuss, and the alternative is to keep counting the infected people while they are getting infected or while they are becoming healthy again, instead of counting from 0 at every act step. Just keep an up-to-date count at all times. If we wanted to do this, we have to go into the person class, because in the person class, that is the class where we know when someone gets infected and where we know when a person is healing again. So for example here in our infect method, where by the way I don't have a comment yet, so when you read something like see something like this, that there's a comment missing in your code, you should always go and fix it. You will get that quite regularly, that happens. So then you go and say try to infect this person. If we are not immune or infected already, we will be infected now. So here is where we become infected. So here we wanted to count how many people are infected. So let's assume we have a variable somewhere that is called num infected, which is the number of our infected people. We would want to increment that variable. The question is now, where can this variable be defined? We are in the person class, because that is where we know when the infection happens. This variable itself obviously cannot be a local variable, because that would disappear after this method finishes execution. But it can also not be an instance variable, because if we make it an instance variable in the person here, then every single person would have their own counter, and that counter would be initialized to 0 in every single person. Every single person would only increment their own variable, and it would just always go from 0 to 1 in that particular person. We need a single variable that is for all persons together. And that is what static variables are for. Static variables are variables that are held in the class. So I can write here private static int num infected and initialize this to 0. So the important thing here now is this is a static variable. So this is a variable that is held not in the person object, but there it is held in the person class. So for all persons together, we have only a single instance of that variable that is stored in the class, and every single person object has access to this variable. So here it gets initialized at the beginning to 0 once, and then when we have an infection, we are incrementing this variable. So now every person, when they get infected, will increment the same variable, and we actually get a count of all the infected people. If you use static variables and you have a number of objects that can all update this variable, you have to think about concurrency a bit and see whether it's safe, because two objects should not try to increment the variable at the same time. Things can go wrong in that case. But in Greenfoot we are safe, because Greenfoot has an execution model where it is actually guaranteed that every object acts in turn, one after the other, one at a time. There is no true concurrency here, so it will be sequential, and that is why doing this is actually safe, because it will be incremented by one person at a time, and if in one act step, say, a dozen people get infected, they will all increment this variable one at a time, and every one of them will be counted. Now we also need to see that we update the variable again when an infection disappears. That is in the heal method here. If we are infected, the infection slowly heals, and when it reaches 0, this is the point where we are healed. So here we should say num infected is decremented. So here we now have the actual taking care of the number of infected people going down again. Just by having this static variable in the person class, and then the increment and decrement when a person gets infected and when they are healing, we are maintaining a continuous accurate count of the number of infected people. So here in the world class, where we are now wanting to display the people, what we're doing now is we have a count already of the number, so we don't actually have to go through here and count all the number of infected people, because we're keeping an accurate count. So the nice thing is, all this code here I can now get rid of. I will leave it there for just a second, and I will first write the alternative, because the question now is, how do we get the number of infected people? Because here we're in the world class, but the number of infected people is now held in the person class. So what we need here is, because the variable is private, and you will have heard me say, if you were in my lecture in PPA, you will have heard me say many times before, variables should always be private. Constants are the only kinds of variable where it is acceptable to make them public, but any non-constant, doesn't matter whether it's an instance variable or a static variable, never public. So if we want access outside of this class to this variable, we are providing an accessor method. Now, the order in which I write the members of a class is always variables first, then constructors, then the instance methods. But static methods I tend to write before the constructor. So static methods come at the top. So here we have now a public, because it's an accessor method, int get number infected is I just said it and I didn't write it. I just said I wanted to make this method static, because it's a static method. It needs so that it can be called on the class, getting the number of infected people, and of course there should be always a comment, return the number of infected persons, and it's quite easy to implement. We just say return num infected. That's all we need. There's an accessor method here. Then we can go back to the world class, and here instead of num infected we just say person dot get number infected. So here, because it is a static method, we call it on the person class, not the person object. The person class now has a static method, so it can be called with a class name in front of it, gives us the number of infected people. Now let's compare here. We have taken the list of all people and went through the whole list and counted how many are infected. At every act step, we counted all the number of infected people. Instead, we have replaced this now with a single method call which just gets the number of infected people, and instead we are keeping the number of infected people up to date as we run the simulation. Obviously, this variant, this alternative implementation is much quicker because we are saving ourselves this having to count. This can all be deleted now. So I take this out of here, and that becomes our new implementation. Let's try that out. Number of infected people is shown here. That works now. We can see that the maximum isn't updated, so we're not quite done yet, but the number of infected people is shown. And the fact why the maximum is not updated is because here I'm still using num infected is my local variable, and I'm not comparing it to this actual number of infected people, because this local variable, of course, I should delete now, and because I'm not maintaining it anymore, and I should use person get num infected instead of instead of the num infected. So if the number of infected people is greater than maximum number of infected, then we use this one. So this we can try out, and now we see it all works again, and the maximum should stay at something. That is fine. Now a few comments about code quality. First of all, here we are calling the get number of infected method in the person class 3 times. Calling it here, calling it here again, calling it here again. Some people will now say, well, if you call the same method 3 times, you should declare a local variable here, call it once, and then use the local variable in these 3 places, because it saves you 3 method calls. Well, it saves you 2 method calls, because once you have to do it still, and then you can reuse that value. In practice, that is not a strong argument. There are optimizers running in every modern programming system, including in the Java virtual machine, that when you write code like this, that will very quickly optimize that out and don't actually do 3 method calls, and actually you end up with exactly the same code in machine code as if you had written that call up front. So the real deciding argument which variant you use, whether you call this here 3 times or whether you use a local variable before, should be what you think is easier to read. So keep your code readable and simple, and leave the optimizations up to the virtual machine that will optimize your code just as much as you would if you made that change now. The second important, interesting consideration is the change I just made. Is that a good thing to do or not? Was the previous version better, or is this version better? I just said this version will be faster, because here this method call obviously is very quick. You don't have to count through the whole list, and maintaining this count here is quicker than counting from scratch at every act step. So this version is certainly faster, and so a lot of people would say this is obviously the better version, and sometimes that is the case. What it actually comes down to is that we always, in many cases, have a trade-off that is available to us. We can pay in either space or time. That is, we can make our program small and make it do more work, or we can use more memory and make it quicker. Because in this case, I have introduced one additional variable here, which is permanently used. And by using this space, by storing the value continuously, I have saved myself the work of having to count over and over again. On the other hand, I could argue that with the previous version, by just counting every time when I need the value and not storing it, I have saved myself some space because I didn't need a permanently available variable. And in practice, it comes down to what constraints you have in your application. Sometimes, well, in this case, the space that I have sacrificed for doing this is very small. It's only a single variable, so it is not very significant. On the other hand, the time to count through a list of just a few hundred objects is actually also not very significant. If you have an interactive application where we're actually seeing something on screen, that is slowed down to a speed, to make it convenient for us to watch. And if we are talking about, sort of the sort of interactive applications where the speed is determined by what the user can actually do or see, counting through a few hundred objects actually doesn't matter. It is so quick, it will not slow your application down. So typically, you ask yourself, what is more valuable to you, time or space? If you are in an application where speed is critical, you would most certainly choose this variant that I have now, where for using just a single variable, I get a speed improvement. On the other hand, if you program for a small device, let's say you write a device driver and you are in a small integrated system, let's say you write code that goes into a car or into a fridge or into a heating system, where sometimes you have only very small amounts of memory, and speed isn't, say, if you program a fridge or a heating system, speed really isn't of the essence, but you don't have a lot of memory, then it might be entirely reasonable to count the value every time you need it and not sacrifice memory. So the question of which version is better cannot actually be answered in absolute terms. It always depends on your context. In our context, since we are running on a full-scale computer, on your laptop or on your PC, you have plenty of memory available. So that's not a shortage in our case, but we also have plenty of time available. So in our case, either version is actually workable. In this trade-off, since the space that we have to pay with only a single variable, I prefer this version, and I think this is probably the more elegant version, where by paying for just use of one single variable, I save myself the repeated counting. So this was an episode about just improving our code, and with the next episode, I promise we will get to actually painting a graph.